Hello students, today we are going to discuss about a new topic, that is ion exchange process. We already discussed water hardness is due to the presence of calcium and magnesium salts. Okay, so we have two types of hardness, temporary hardness and permanent hardness, in which temporary hardness can be removed by boiling. And this method, ion exchange process, is mainly used to remove permanent hardness. So we have ion exchange process to remove permanent hardness. We know that permanent hardness uh, is due to the presence of chlorides and sulfates of calcium and magnesium. So in order to remove permanent hardness from water, we have to remove the chlorides and sulfates of calcium and magnesium. And it can be removed by this ion exchange process by using ion exchange resins. So mainly ion exchange process is carried out by using ion exchange resins. Okay. Then ion exchange resins, they are basically water insoluble long chain cross linked organic polymers having exchangeable ions H plus and OH minus ions. They are basically water insoluble polymers carrying the exchangeable ions either H plus ions or OH minus ions. Then how it works? That is, we have water with permanent hardness, calcium and magnesium. So we have hard water contain permanent hardness, in which calcium 2 plus and magnesium 2 plus are the cations present in hard water. Cations means species carrying positive charge, and sulfates and chlorides are the anions carrying negative charge present in hard water. Calcium and magnesium are the cations present in hard water. Sulfate and chloride are the anions present in hard water. Permanent water contain permanent hardness. When we pass this permanent hardness water contains water through this ion exchange resins. We know that ion exchange resins, they are basically polymers, water insoluble polymers having exchangeable ion H plus ions and OH minus ions. When we pass this hard water through this ion exchange resins, all the cations present in hard water, that is calcium 2 plus and magnesium 2 plus, they will exchange with H plus ions present in hard water, present in ion exchange resin. That means calcium and magnesium, calcium 2 plus and magnesium 2 plus, trap into this ion exchange resins, and this H plus ions release into water. They exchange with each other. Similarly, sulfate and chloride are the anions present in hard water. When they pass through ion exchange resins, the OH minus ions exchange with this anions, sulfate and chlorides. So the sulfate and chloride trap into this ion exchange resins, and OH minus ions release into water. So when we pass hard water through ion exchange resins, and finally we will get soft water, that is all the calcium, magnesium and sulfate chloride will be trapped into this ion exchange resins, and H plus and OH minus ions release into water. So after ion exchange process, that is passing through ion exchange resins, we will get soft water, or we can remove permanent hardness. Similarly, so we have two types of ion exchange resins. We have cationic ion exchange resin and anionic ion exchange resins. Cationic ion exchange resin always carries H plus ions as exchangeable ion, and anionic exchange resin always carries OH minus as ion exchange resin. So cationic exchange resin can be represented as RH plus, where R is the water insoluble long chain organic polymers and with exchangeable ion H plus ions. Similarly, anionic exchange resin can be represented as ROH minus, where R is the long chain organic polymer and OH minus is the exchangeable ion present. So how this ion exchange resin? In order to carry out this ion exchange process, we have two columns, column 1 and column 2. First column is filled using cationic ion exchange resin, that is RH+, and the second column is filled using anionic ion exchange resin, that is ROH-. Below to this we have a layer of gravel bed. Gravel bed is mainly used to remove the impurities or used to remove the turbidity present in hard water. So we can remove all the impurities, and after the removal of turbidity and impurities we will get clear water when we pass through this gravel bed. Gravel bed is mainly created using some soils, etc. So main purpose is filtration, and both this column 1 and column 2 connected using a pump. Okay, so how it works? When hard water, mainly hard water, contain permanent hardness, and calcium, magnesium 2 plus, sulfate, chloride are the main contents in this hard water. When this hard water passes through the first column, when they move through this cationic exchange resin, which contain H plus ions as exchangeable ion, all the cations present in hard water, that is calcium 2 plus and magnesium 2 plus, is exchanged with this H plus ions in this cationic exchange resin. So all the calcium 2 plus and magnesium 2 plus ions trap into this cationic exchange resin, and the H plus ions release into water. And after they move through this gravel bed, and using this pump we insert this water into the second column. When they move through this second column and they pass through this anionic exchange resin, all the anions present in hard water, that is chlorides and sulfates, exchange with OH minus ions in this anionic exchange resin, that is chlorides Cl minus, sulfate SO4 2 minus, trap into this anionic resin, and OH minus ions release into water. So finally we can collect soft water after this ion exchange process. So process is working is simple, that is when we pass hard water through this first column, all the calcium magnesium 2 plus ion exchange with H plus ions, and using a pump when we pass hard water through this second column, all the anions chloride and sulfate exchange with this anionic exchange resin, and finally we can collect soft water. Okay, after the continuous use of this both resins, the calcium and magnesium 2 plus ions filled in this cationic exchange resin. Similarly, chloride and sulfate filled in this anionic exchange resin. This condition is said to be exhaust, that is this cationic and anionic exchange resin is said to be exhaust, that is there is no further exchange take place from this cationic and anionic resin. At that time we have to regenerate or recycle this cationic and anionic resin. So in order to regenerate cationic exchange resin, first we stop this hard water flow and we will spray acid to this cationic resin. You know that acid mainly contain H plus ions. So when we spray acid to this cationic exchange resin for regeneration, all the cations calcium 2 plus and magnesium 2 plus filled in this cationic exchange resin exchange with the H plus ions from acid. So calcium and magnesium ions will move into this wastage to sink, and this cationic resin filled with H plus. Similarly, anionic exchange resin is regenerated by spraying alkali. Alkali mainly contain OH minus ions. So when we spray alkali into this, the chloride and sulfate ions exchange with this OH minus ions. So chloride and sulfate will move into sink, and we can regenerate anionic resin using this alkali spray. So this is a regeneration methods, that is when cations and anionic resins become exhaust, we have to regenerate them. In order to regenerate cationic exchange resins, we spray acid. In order to regenerate anionic exchange resin, we spray alkali. Okay, this is about the ion exchange process. Okay. So we have two columns of cation exchange resin and anion exchange resins. First it prepared, and hard water first passes through this cationic exchange column. All the cations, calcium 2 plus, magnesium 2 plus ions are exchanged with H plus ions. And we have the exchange reaction, that is RH plus. That is our this RH plus cationic exchange resin exchange with the calcium 2 plus present in hard water and forms R2Ca, and this H plus ions, 2 H plus ions, release into water. Similarly, hard water contain magnesium 2 plus ions. What will be the exchange reaction? That is RH plus, our cationic exchange resin, exchange with Mg2 plus present in hard water and forms R2Mg, and 2 H plus ions release into. Then after that, hard water pass through anionic exchange column using a pump. All the anions, that is sulfate and chloride, present in hard water are removed by exchange with OH minus ions. What will be the exchange reaction? We have ROH minus, that is our anionic exchange resin. Where it exchange with chloride present in hard water and forms RCl, and this OH minus ions release into water. Similarly, hard water contains sulfate SO4 2 minus, exchange with ROH minus and forms R2SO4 and release 2OH minus into water. These are the exchange reaction. Why we so capacity of exchanges allows to exchange H plus and OH minus ion. It is said to be exhaust condition. At that time we have to regenerate or recycle our resins. Exhaust cationic exchange column can be regenerated by passing acid. Example, dilute HCl or dilute sulfuric acid. What will be the exchange reaction? The exhaust cationic resins in the form R2Ca. When we spray acid 2 in, H plus is the main content in acid, it will forms RH plus, that is our exchange resin, cationic exchange resins, and calcium 2 plus move to zinc. Similarly, exhaust anionic exchange column can be regenerated by passing alkali or spraying alkali. Example, dilute NaOH. R2SO4 is our exhaust anionic exchange resin. When we spray alkali OH minus into it, it forms our ROH minus, that is anionic exchange resin, and sulfate move to zinc. So regenerated ion exchange resin, both the cationic and anionic ion